Hey, welcome back. I have a good amount of these plastic parts to machine, OD, ID and CNC milling, and for the ID work I have to take off quite a bit of material and I wanted a secure way to hold them, and normal outside stepped street chuck jaws, what a word, have not very much surface that holds on to the part. And when you take a quite heavy cut, like the whole width of an insert, which is in PVC not a problem at all, it can happen that you lever the part out of the jaws and create a quite entertaining crash. So the better solution, in my mind, are pie jaws, like these. They're basically soft jaws with a huge contact area to the part, and they're easy to make and work beautifully. I have a set of master jaws that I can bolt anything to that I want. So let's go to the procedure of making them and yeah, look at the CAD and CAM, cut them out on the CNC router and go from there. Oh, there we go. That's a very solid grip. No worries that this part will ever come out during machining. Here we have the pie jaw. It starts out as a piece of 100mm aluminium, and we machine those features herein. Those match the master jaws I have. The way I modeled this is I have a sketch here, which has basically every single dimension in it, which looks quite messy, but this way of modeling has some advantages. Then you just go back and pull every dimension out into an extra model with all the solid features. Then we go into CAM, and I have to separate all the programs for each. I have to do extra operations for each tools, and I have to do extra setups for each tools because I do not have a tool changer on the machine, and it's the easiest way to do it for me. So I have a setup for 4mm end mill, 2mm end mill, and down here is a chamfer end mill. The way I do is I cut these areas that are accessible from the outside as a 2D profile, just entering from the outside and slotting them out. And I have a 2D pocket here, spiraling down and then just pocketing it out. 2D contour finishing those profiles, 2D contour finishing this inside profile, 2D pocket finishing the bottom surface of this feature, and spiral milling those counterbores. The 2mm tool only cuts those 3 slots. These slots only are there so I have a guide when I cut them through with the bandsaw. And last but not least, chamfer end mill, 2D chamfer, walking all the way around to chamfer the part. So let's hit simulate with this material, not showing the tool paths. There we go. There we go. That's all the all the features cut. That's the chamfer end mill. Obviously I didn't take the stock from the previous operations over in the other because it's not necessary for so simple processes. I'm set up to cut another one of the pie jaws on the CNC router. I have a 3-jaw chuck clamped to the table. I have a 4mm 2-flute carbide end mill in here. I do not have a tool changer or a tool tool length probe or something like that. I do it the old school way with a 3mm gauge block and touch off manually. The way I like to do is I jog down until I can't get the gauge block under the end mill, and then I jog up in 1/100ths of a millimeter increments until the gauge block slips under the end mill, like this. Then my offset to the top of the part is 3mm. And I prefer to have the offset of my work offset on top of the part. I know a lot of people put it on the underside of the part, or in the, which would be the bottom of the vise or the jaws that hold the part, but I have been burned by that before. I prefer it top here. Program is loaded. I have 3 tools, 4mm, 2mm and a chamfer mill. I have 3 individual programs. And yeah, let's go. This is slightly different from the machine at work. At work I run a Datron M10 Pro with 40,000 RPM spindle, Renishaw probe and tool length probe, and a 22 station tool changer for HSK 25 tooling. That machine makes quick work. This here is way more raw and way more basic, but it gets the job done. And basically I bought this machine for one specific job, and it paid already for itself, so meh. And when the moment comes along and I find a cheap tool changing spindle for this machine, I will throw it on here. Changing to a 2mm carbide end mill. I might invest in a new brush someday. And another tool change. These are not exactly DMG linear machine tool changing times. And there we are, finished bottom side of the soft jaws. These are the slots that register into the master jaws, and this part here indexes them on them. Over at the manual mill, drilling the pie jaw. I'm using this is an outer race of a ball bearing as a parallel, because it's round, nice and useful. And I just clamped the round block and the vise without bothering for alignment. I'm just lining the drill by eyeballing up with the pre-milled holes I put in there. And because I don't want the part to tip over, I put a screw check on both sides, just to be on the safe side when I do the drilling. Drilling puts a lot of axial force in the part, and you do not want to tip it over. So these are just clearance holes for screws, so there is no high precision involved. 6.5mm drill for an M6 screw. That's plenty of clearance. First side done. Now we can take all the stuff out of the vise. Change to a piloted counterbore, because these don't help much if the screws are on top of it. You want to sink the screws in very deep, so you have a lot of meat of the jaw to machine away. So basically I want to leave about that much material. Setting my depth stop and dropping it in. And in this case it's even easier, as this is a piloted tool. I just line it up, drop the vise handle, clamp it, and I'm good to go. The nice thing about aluminum is that you can run the tools crazy fast. Next one. And I'm using alcohol to prevent the tool from seizing up, and the aluminum, whatever. Not because alcohol is a great lubricant, but because it is a pretty bad lubricant, but it evaporates and leaves a clean machine afterwards. And as the CNC made us nice nice lines so we can bandsaw it apart, that's what they're going to do. Be careful when you cut from, when you have a round disc and you cut in from the outside. Stresses in the material will pull the cut shut, and it will have a hard time to get the bandsaw blade out. So, as you saw, I didn't cut all the way in. I marched my way around and incrementally went farther in, which makes the stresses around the round part can be kept in a balance that way, and you're not pinching the blade. On the first one I cut all the way to the center, and the cut closed completely on the end, and that took some maneuvering around with the bandsaw blade to get it out again. But this walking your way around it works pretty darn good, I have to say. So there is my second set of pie jaws. I will mark them with a number so I keep them together and do not mix them up. Deburring the soft jaws. I don't want to cut myself on the sharp edges here. It's nice when the jaws are not razor sharp where you're bored and cut them, whatever did to them, but are nice and smooth to the touch. So let's see. Piece of PVC. And this is a secure setup. This part is not going anywhere. Yeah, this is rigid. I like it. By the way, this is the second op. I was thinking that you might be interested in this fixture too, or in this setup. I have a nut here and a washer, a C washer, which is basically just a piece of PVC scrap with a slot bandsaw in, so I can slip it over this M8 stud. And the slot is there, so I do not have to unthread this nut each time I change parts over. And the part it's just a snug fit on this disc of Delrin, bolted to a faceplate. This is bolted with two M8 screws to a faceplate, turned true and to a close fit on the inside of these PVC parts, and I slipped the PVC part over. Why not actually do it with an actual part? Slip the part over it, make sure it's resting against the face, get the washer, lock it, do not over tighten it. The part can basically not go anywhere. This is a very safe and rigid setup, and also very repeatable and very precise. Each time when you can do something with an arbor and a register, chances are pretty high that your that the results will be quite precise. The only thing that's annoying is with PVC, it's really hard to break the chip. I'm using polished aluminium inserts, CCMT0602, and I tried feeding them with 0.3 millimeters, and then they start to break the chip, but below that you get this 1000-meter string of chip that you have to handle. That's also the reason why I run it so slow. If I run it that slow, the chip just falls off the lathe and does not wrap itself around the chuck and the part and the tool and messes everything up. So yeah, that's the joys of working with plastics. I was thinking, while I'm here, I can show you what these parts are going to be anyway, because you haven't seen me do much CNC work on this new machine, so why not show it a little bit. After the parts are turned on the lathe like this, they go on the CNC in the 3-jaw. And I machine these ratchet teeth on the inside. Complete machining is done with a 4mm carbide ball end mill. Roughing and finishing, which is not a problem with PVC at all. Tool wear doesn't happen in this material. I only left with a little bit of burr on these edges here, which are not a problem because I'm hitting the inside anyway with Scotch-Brite. And as you can see, this is a normal 3-jaw chuck. No soft jaws, no pie jaws. And I do not get any marking on the part here. And the reason for that is I do not crunch down on this chuck like crazy. I'm just tightening it down enough to hold the part during machining. Knock it down onto the horizontal steps of the jaws. Offset is already set because I machined the part already. And okay, here we have the part in CAD and CAM. As you can see, I have actually two components. I have the actual part with the saw teeth and everything in it, and I have this thing here, which will also serve as the stock model for the cam operation. But also this is what we're going to make on the lathe. That's all the operations I can do on the lathe without a problem. And then I go over to the CNC router and have it cut the teeth into it, which I obviously cannot do manually. At least not without getting completely mad at myself. So let's change to cam. And as you can see, I have the stock is the model that I did beforehand. And we start by walking down with a 4mm ball end mill down the wall. That's because of those round bosses here. Then we go down again with a larger step over for finishing. And then we rough out the pockets here, 2D pocket operation, to rough out the saw teeth. Then it's quite simple, just 3D contour, same 4mm ball end mill, and waterline finish everything, which takes about 15 minutes. I'm going 2000mm per minute feed rate at roughly 10 to 15,000 RPM. The RPM in here has nothing to say because I set the speed, the spindle speed on my CNC router manually. Depth increment is 0.1 millimeter. And then I have a drilling operation that just goes down 0.5 millimeter on each of the holes to create a dimple so I can drill them open later on the mill manually. I'm not going to drill those holes 40mm deep all the way through on my CNC router. That would be a bit painful with the with the relatively fast running spindle. And the PVC is really a material that tends to gum up and burn and melt and create quite a mess. So I'm doing that manually. So they don't look perfect off the CNC router. I get a burr here that I could avoid with a slightly better toolpath, but why bother for 6 parts? I will have to make, I think, about 20 in total of these. So I might optimize the toolpath a little bit. This evens out all the tool marks a little bit, removes the fine fuzzy burr that the tool leaves in this very soft plastic. I'm not a big fan of PVC. It machines okay, it's very soft, but it's hard not to get a burr. So That's better. I will do a little bit more to it. I had the ball mill do me the center drilling because I'm not going to drill 40mm deep on my CNC router. I'm going to drill these on the manual mill all the way through. But apart from that, I'm quite happy how they came out. Machining time on the router is about, I think, 30 minutes for all the ratchet teeth, roughing and finishing, and I get a pretty good finish on the actual teeth surface here. And while the CNC router in the other room is finishing the PVC parts, I can turn the Delrin parts that go along with this job in another set of pie jaws that I've turned. Right now I use them to clamp the part on the outside, but later I will modify them so they clamp this piece, which will look like this, hollow on the inside. I will modify the jaws so I can clamp this part from the inside and machine the OD and the face of it. There we go. Here you will see how well this chuck holds such a part, even as it gets thinner and thinner around the walls. We start by punching a hole through. The finished part will have a 12mm hole anyway, but I will do that along with all the other holes in the top on the CNC router. For now I'm just blasting through a 10mm pilot hole so I can get with boring ball. Just a facing cut to clean up the face, obviously, and give me a 0. There we go. That's all. That's all the massive material removal done in the first setup. Now I just have to take a grooving tool with a 1.5mm radius and cut an internal groove, touching off on the face of the part, offsetting by 1.5mm, which is the radius. Going in, remove my stop, going in 17mm, going down with the speed a little bit, 350 RPM. There we go. Change to a 3-degree chamfer tool, which is a weirdo, but it works. Needs very low speed because I have very large engagement. Look at that chip, almost like foil. The drawing specs a 9.5mm wide chamfer. That's a very open open tolerance, so I'm just checking it with scale. That's good. Okay, now I need to hold these parts from the inside, like this. And I'm going to take the same jaws that I have. I preloaded them in the center with a pin that I clamped on. And you do this always, or yeah, make sure you always use the same pinion drive on your chuck, because that way you always preload the chuck the same way. There is nothing squirming around if you always use the same one. That's also the reason why you should use always the marked pinion drive when you use the stock hard jaws, which I'm not doing in this case. But I'm still using the marked pinion drive, so it's easier to keep track. There we go. Now we just turn this down to 102.3 millimeters. All of you guys pretty much were already screaming at their computer because I'm telling you all this stuff about repeatability and using the same pinion drive and yada yada yada, but I preloaded the chuck in the wrong direction. I preloaded it from the inside, which you do when you want to do ID work, but when you want to do OD work on soft jaws, you need to preload it from the outside. Yep. So I had a large hose clamp, and I wrapped it around, and now I can preload the chuck in the other direction and pull this pin out. So now we are preloaded in the right direction. And no, this is almost not dangerous, so better be careful. This thing can bite you. Okay, this should fit. Let's get this. Let's get this hose clamp off. There we go. That's a nice rigid setup now. Hitting the edges with a chamfering tool, and I think it's done. Last operation will be on the CNC router to drill all the holes and mill out the center hole. But apart from that, there we go. So this is a clear case where making some specialized tooling, in this case the soft jaws and the arbor, makes the job so much easier to get done. It's not always about heavy material removal rates and crazy high feed rates. Sometimes it's just about holding onto a part safe, reliable, and repeatable. Think about that. So, thank you all for watching and see you next time.